Okay, let's begin with question number 10 on this paper now. Okay, let's move it to a whiteboard, please, and we shall begin. Okay, let's see. Let's read. See. In the diagram, this is a vector question. It's a vector. OA is A, OB is B, so standard position vectors, labeling. Okay, AM is MB, these two are equal, and OP is equals to 1/3 OB, 1/3. This is important. 1/3 means of the OB, that means 1 to 2 the ratio. So think of it like that. Okay. That direction. So express AP and OM in terms of AB. Let's do that first, please. So AP will be AP, we just use the relation AP, sorry, writing OP. Okay, AP equals to, just think of vectors like triangle walking before. So A and P like that means, like that means you're walking from here to here. Same as walking from here to here plus walking from here to here. So that will result in that. Kind of like that. Okay, so AP is walking from, same like walking from A to O and then O to P. But AO is not given, but we have negative, it's negative of the OA when you flip. So OP like that. So from here, we can deduce that this is negative of A, OP is what? OP is 1/3 of OB, so 1/3 of B. 1/3 of B. So therefore, this is the answer already. You can just leave it like that. It's not an issue. Okay, let's try to do OM plus. Likewise, so OM equals to, so if we look at the other triangle now, something like this. Triangle like this, for the A, this is M, this is O. So if I want to find OM, it's the same as walking from O to A and then A to M. Okay, so OA plus AM. Then I deduce this further. OA, no problem. OA is given as A, so it's an easy part. The AM part, still got a bit of problem because AM not obvious. So AM, we use the fact that M is a midpoint of AB, meaning that AM is half of AB in that direction. So vector-wise, we write like that. So half of, in the brackets, we add a O, AO plus OB now, split further inside. Because all is related back to the position vectors or vectors which are given in terms of that. So that's why we need to write it like that. So this is negative OA plus OB. Okay, now we're ready to substitute all those values. So this is A plus half. What is in the bracket? Negative A. This is negative A. OB is what? Plus B. Ta-da. Okay, now it's just a matter of a bit of algebra. So that means A minus half A. And this side is plus half B. Okay, so finally we get the answer as 1 minus half, 2 minus 1. Half of A plus half of B. Okay, some people will write it like half factorize A plus B. Also can. Okay, it's not wrong. All these are correct, Please take note. Okay. So we don't know we're going to use these parts from the second part of the question. So what I'm going to do is just going to cut and paste them down here so we may look at it closely, just in case. Take a quick screen grab while we're waiting for that. Okay. So next we're going to do that part down there, the other part, the second Roman numeral. After I take the screen grab, I just write OM down here. If I take a screen grab. Okay. OM. There, my calculations are all correct and no algebraic mistake or anything, hopefully. So, hopefully. Let's just put it here first. Okay, the idea. Okay, let's try to capture the idea. Okay, accuracy is also important for exams. Okay, let's go for the second part. Given that OQ equals to lambda, there's a symbol called lambda, it's a Greek alphabet. OQ equals to lambda OM. Express OQ in terms of lambda A and B. So they want you to express into OM. So if you look at it carefully, the OQ part, just lambda A and B. So lambda is OM we just take from the earlier results. Okay, that's why I mentioned this. So just want to show the arrow. Ta-da-da. from here. OM, which we already got, in case you are wondering. So it's a half inside there, in a bracket B, like that. So it's not hard to see that all we can do is just write lambda over 2 in terms of lambda, that part, bracket A plus B, finish. That's it. Just multiply that. Nothing further can be deduced from here. So let's go for the third part, please. So third one, this is done. Now we're going for this. Given that AQ equals to mu, that's another symbol. Mu is spell that mu. Okay. It's another symbol in the Greek alphabet. So likewise, used heavily in maths and physics to represent things. Okay, mu of AP. So here we are. AQ equals to mu AP. Express OQ in terms of mu A and B. So I want to find OQ. There's no OQ here. So how do we do that? So we just recreate it. Please take note. I introduced the AO plus OQ. Okay, you're wondering why I'm writing that. Just to show the emphasis on the position vector, which is the OQ. Just add an O. Working from A to O, then O to Q. Don't need a picture also. Notice you can just think of it visually as well. So AP is where? AP is given very earlier we found. So this is where we use this. So I said they might use the earlier results. They won't tell. Please take note. Sometimes they won't tell. Sometimes they might tell. So we have to figure it out. Now that's the challenge. So we write here, this AP becomes bracket, just copy it, minus A plus 1 over 3B. Okay, seeing this thing. Okay, let's try to simplify this part, please. So this is minus OA. Okay, this is plus OQ equals to mu. Minus mu A. Easy to write like that. Let me just write it nicely. You multiply this with this and that with that. And this times this times this. Minus mu A plus mu over 3B. Mu over 3B, this one is minus mu A. This side, now I'm going to change this side, please take note. Should have substituted it out, but just want to show, emphasize a little bit more in details. Don't get confused. That's a mu in my handwriting. It's quite horrible, actually. Just kidding. Okay, so this is minus A plus, because OA is given as A. OQ is what? So we need to think about the OQ part. Did we find OQ? No, because OQ is what they asked us to find. So that means rewriting this, bringing this to the other side. So we can easily see that minus mu A, like that, plus A, when I regroup it, plus mu over 3, write the BL together. Okay, let's write it nicely, please. So this is OQ, like that. And then for this one, I'm going to write in green. Dark green, OQ equals to 1 minus mu of the A plus mu over 3, mu1 says mu, of the B. Okay. So this is the answer for part 3. Hence, find the value of lambda and mu. So I'm just going to take 2 screen grabs to complete that part. So we need to link the answers for part 2 and part 3. So I'm just going to kind of paste like that. 1 minute plus. Finish off this question. Okay, let's cut and paste first. Nicely. Okay, let's clear the whole thing, please. Ta-da! Okay, magic. All right. Let's click it back and continue. Ta-da-da. Okay, OQ like that. So if you notice carefully, how do we do number 4 now? Is we equate it suitably. That means equate it suitably means first I take the lambda over 2 of the A plus lambda over 2 of the B. So that means these two are, we equate the coefficient of A and the coefficient of B. Likewise. You understand? Huh? That means in front of the A here is lambda over 2. In front of the A here is 1 minus mu. So we're going to write like this. 1 minus mu, based on the red arrows, they're pointing it to a lambda over 2. So how did I get this? Equate coefficient. Coefficient means the number in front is multiplied of vector A. Okay, at the same time, now I'm going to do the other side like that likewise. Please take note. Just different color. Okay, so this one coefficient. So this part is put like this, a bit of a sporadic writing. Sorry about that. Equate coefficient of B. Vector B. So in front of b here is lambda over 2. So same lambda over 2 I didn't copy. So I'm straight away writing equals to mu over 3. So notice that? Okay, now we need to solve. Solving part, we just think of it abstractly, algebraically, detach the meanings. So these two are equal. So 1 minus mu equals to mu over 3. Multiply out plus 3 minus 3 mu. Okay, I don't want to deal with fractions. So I just multiply by 3 throughout. So 3 equals to mu plus 3 mu. Aha. So in other words, 4 mu equals to 3. Finally, we can get this part, one part here, which is mu equals to 3 over 4. So it's one of the answers in the collection box here. We put it like that. Back to the answer, 3 over 4. So let's put it back in here. This is a different color to indicate that. Put back. So put back means we're solving for lambda over 2. Let's say I write it in color. Either way you can do it. This is easier. So I'm just going to use lambda over 2 equals to mu over 3. If you equated it with 1 minus mu, so you'll get the same answer. Okay, let's say no to lead to the same answer. Okay, so let's substitute and solve this first. So lambda over 2 equals to mu is 3 over 4. So this is 3 over 4. And then there's a denominator as another 3 there. Ta-da! Oh, so we cut and see that this equals to 1 over 4. Okay, we'll put in calculator as in to be safe. So calculate the last part, please, equals to something times 2 because the 2 goes over. This is the 1 over 4 there. So when you multiply this, we get the final answer. Correct, calculate the correct means that lambda ought to be 1 over 2. Thank you.